Fundamentals for Engineering Mathematics section, Final Exam Revision, questions 15 and 16. So question 15, we're wanting to differentiate. If we look at our first equation here, y is equal to x squared plus 4x plus 3. So here we differentiate dy on dx. We bring our 2 down, 2x, 2 minus 1, so it just becomes 2x, plus 4, and our x disappears there. So 2 is a little bit more complicated. We've got our y is equal to 4x squared plus 3 to the power of 5. And so here we can say, well, let u equal to 4x squared plus 3. Therefore, y is equal to u to the power of 5. And we went through this and we said, well, dy on dx, and we can differentiate u with respect to x, is du differentiated with respect to x multiplied by y differentiated with respect to u. So our du's cancel out and we get dy on dx. So if u is equal to 4x squared plus 3, then du on dx, u differentiated with respect to x, the 2 comes down, 4 times 2 is 8, x and 2 minus 1, so it's just x, and our 3 constant disappears. For our y is equal to u to the 5, we differentiate y with respect to u. So we bring the 5 down, and we've got u 5 minus 1 to the power of 4. And we can substitute our u from up here back in. So we get 5 lots of 4x squared plus 3 to the power of 4 now. So we come over here, we've got dy on dx is du on dx, which is 8x multiplied by dy on du, multiplied by 5 with 4x squared plus 3 to the power of 4. 8 times 5 gives us 40x. Then we've got 4x squared plus 3 to the power of 4 there. Okay, so moving on to number 3. So here we're going to use our quotient rule here. So our quotient rule, we say dy on dx here is v times du on dx minus u times dv on dx, all divided by v squared, where here at the top that is our u and at the bottom that is our v. So we're saying let u equal x plus 5, so then du on dx is therefore just equal to 1. And here we'll say v here is equal to 2x plus 3. We differentiate with respect to x here, and we end up with 2. So dy on dx is equal to v 2x plus 3 multiplied by du on dx, which is 1, minus u, which is here, x plus 5 multiplied by dv on dx, which is equal to 2, all divided by v squared, which is here at the start, so 2x plus 3 all squared. So here 2x plus 3 multiplied by 1, we just end up with 2x plus 3. We're on 2x plus 3 all squared. Here we've got minus, and we'll put our 2 in first and then we'll work through it. So here we've got 2x, and then 5 times 2 is 10. So here we're going to have, well, 2x plus 3 minus 2x minus 10. So I've kept this in brackets to make sure I don't forget that this negative applies to that 10 as well. 2x plus 3 all squared. 2x minus 2x is nothing. 3 minus 10 gives us minus 7 on 2x plus 3 all squared. So now when we look, here actually put a line in. So these were all for our question 3. Now we're looking at number 4. And so number 4, we're going to be using our product rule here. So here we have, this will be our u and this will be our v. So our dy on dx is equal to u times dv on dx plus v times du on dx. So u is equal to x cubed plus 2. du on dx is therefore equal to 3x squared, and the constant disappears. v is equal to 7x plus 3. dv on dx is therefore equal to 7. So our dy on dx is equal to u, x cubed plus 2, multiplied by dv on dx, 7, plus our v, 7x plus 3, multiplied by our du on dx, which is 3x squared. So working this through, we get 7x cubed plus 14, plus, so we've got 7x, so 7 times 3 is 21, x, and here x squared, we're getting x cubed, plus 3 times 3 is 9, x squared. So here 21 plus 7 is 28, x cubed, plus 9x squared plus 14. Okay, so now looking at question 16. We're wanting to solve these following equations. So if we look here, equation 1. X multiplied by x minus 2 is equal to 8. So we can multiply this out. X times x is x squared, minus 2x is equal to 8, and we can minus 8 and minus 8. So we get x squared minus 2x minus 8 is equal to 0. We have a negative at the end, so we're going to have x minus and an x plus. If we had a minus and a minus, this would be a positive. If we have positive and positive, positive. So we must have a negative and a positive. And we think about, we can do, well, 8 times 1 is 8, but we're not going to end up with 2. And 2 times 4 is 8. So 2 times 4 will work. If we have minus 4 plus 2, then x minus 4 is equal to 0, x is equal to 4, x plus 2 is equal to 0, x is equal to minus 2. So now we look at question 2 here. We've got x minus 3 all squared is equal, or minus 29 is equal to 0. So what we're going to do first of all is move that 29 over. X minus 3 all squared minus 29 plus 29 is equal to 0 plus 29. So x minus 3 all squared is equal to 29. So if we take the square root of both sides, we know, well, x minus 3 is equal to plus or minus the square root of 29. So negative 29, or negative square root of 29 squared will give us positive 29, and same with positive there. So we've got positive or negative 29. So here if we have x minus 3, we're going to add 3 to both sides. X will therefore be 3 plus or minus square root of 29. So we can leave this in exact form and have, well, x is 3 plus the square root of 29, or x is 3 minus the square root of 29, or we can round this off and we put this in our calculator and we should get 8.39 to 2 decimal places, and x is equal to negative 2.39 to 2 decimal places. So now looking at number 3 here, we've got 9x squared is equal to 81x. So first thing we're going to do is move it over, so we're going to minus 81x on this side and minus 81x on this side. 9x squared minus 81x is equal to 0. We look, 9 and 81 both have a factor of 9. X squared and x both have a factor which is x. So 9x times x will give us 9x squared. 9x times negative 9 will give us negative 81x there. So from this, either 9x is equal to 0, divide both by 9, x is equal to 0, or x minus 9 is equal to 0, we add 9, x is equal to 9.